Thank you very much, Tino. My name is Ravi Pappu. I'm a co-founder and CEO of Apeiron Labs. And today I'm going to talk a little bit about our approach to scaling ocean data and ocean observations. I got into the ocean world completely by accident. I'm not an ocean native like many of you. I grew up as far away from the water as you can be in South India. But 10 years ago, I happened to run into Mark Abbott, who was the former president of Woods Hole. And my whole professional life has been making really low cost, uh, high volume things. So if you've ever been to Disney in the past, 10, 15 years, some of you have worn these bands. I did some of the original research to show that that could work. So things that are deployed at massive scales. And Mark Abbott at Woods Hole was focused on making really expensive things that go to the bottom of the ocean, but there's just one or two of them. And when we got talking, we started asking the question, how can we do a 10x improvement in the cost of ocean data? And that's how I got to this world, and here I am. Now, many of you have heard about Moore's law, which is the reduction in cost of computing or the increase in speed of computing, essentially the doubling of computing power every 18 months. But there's an equally fascinating law in stuff, in making things. It's called Wright's law. It was discovered by a guy called Ted Wright, who was trying to make large numbers of aircraft in the early part of the 20th century. And what he observed is every time you double the number of units you make, you cause the cost to drop by a fixed percentage. Now, this is not magic. It's not preordained. You have to work to do it. But all the factors involved in scaling up production, and if you're smart about it, they conspire to lower the cost by a fixed percentage. So I have three examples here. It's an eye chart. Don't bother about the details. But the key idea is when you double the number of cars, you drop the price per car, the cost per car by about 15%. Same thing for lithium ion batteries or solar modules. The, the, the reduction in cost of solar modules over the past 50 years has been stunning. Something that cost $100 in 1976 now costs 30 cents, that same capacity of solar, which is absolutely stunning. But this didn't happen, like I said, by magic. It took decades. The x-axis on any of these charts is a few decades. But importantly, this is also not just purely technological. It involves industry cooperation, it involves government policies, innovative financing mechanisms, and so on. So all of these things, you can boil them down to a single number. By how much does the cost decrease when you double production? And typically, historically, across many, many industries, the range is around 10 to 30%. Even beer. So you can see where I'm going with this, but let's look at our problem for a second. I'm going to use Argo as an example because I think it's a fabulous project. But as many people have before me have spoken and said, Argo is not scaling at the rate that we need it to. But I picked it because there's a long baseline, 25 years of Argo. So we have, enough time to look at it. There's been a huge impact of all of the Argo data over the past 25 years. And the marginal utility of every new Argo data point is phenomenal. Every new Argo data point has some impact, either in understanding the oceans or in actual forecasts that affect our daily lives. So I picked this, and this is a chart from NOAA actually. But basically, we are actually, instead of moving down the experience curve in Wright's law, I think on the Argo side, we're actually moving the wrong way. There are fewer floats today than they were in 2018. And it looks like the cost per profile has actually gone up a little bit. So let's take a quick look at the economics of Argo. Publicly available data shows that it costs, $200 to $300 per profile, and half of that is hardware and half of that is everything else. So if you take the $300 number and magically all of the hardware became free, it would still cost $150 per profile. And there's really not a path there to scale it by 10x, make it 10x cheaper or 100x cheaper or 1000x cheaper. Because of the way the program itself is funded and structured, there's a challenge in scaling. And you can see that in the top chart here. So, from my perspective, I think starting with a $300 per profile and asking, how can we lower the cost, given the funding structures and the funding mechanisms, is going to be sort of a really tough hill to climb. So, how about a different approach? So my question to all of us, and I'll show you how we are working on this, is how can we collectively create and coalesce around a roadmap that yields an exponential improvement in the cost of ocean data over time? And this over time is important. I'm talking about a decade, 2 decades, 3 decades. I know it always feels like we don't have enough time, but if we don't think about this over time now, we're not going to get there. So the right approach to ocean data is, instead of starting with where we are and saying how can we lower the cost, I propose that we ask the question, what do we need the cost to be? Question number one. If we say, and Craig mentioned that we are 4 to 5 times undersampled as far as Argo is concerned, I'll add to that by saying the littoral areas need, all of the data. We don't even have that Argo data at any Argo type data at any scale, because Argo is essentially an open ocean network. So we can say, let's ask for a 10x reduction in the cost per profile. And I'm just using subsurface vertical profile data as an example. If you want, you can have, the cost per square kilometer or some functional metric that you're trying to optimize. And then we say, how can we architect the observing system to harness as many experience curves from other industries as possible? I don't think we can invest our way into this 10x or 100x or 1000x, given the funding structures that we have today. We have to leverage investments from a whole bunch of other industries. And this is the crucial part. So we start not with where we are, but do a cost target and then say, how can we architect our system to take advantage of existing industry? So that's what I call the right approach. And we've been following this at Apeiron Labs for a while. That's the whole thesis of our existence. We are a startup that's based in Cambridge, Massachusetts, and our approach has these 3 pillars. So this is our equation: arrays of really low cost autonomous underwater vehicles. They don't go to 2,000 meters, they go to 400. But this is what they look like. Uh, Whoops. I think the background is messing it up, but I can show it to you. But they're portable, really tiny. But our goal is to leverage all of the advancements in manufacturing, rapid prototyping, electronics, satellite communication, and so on, but in a very systematic and deliberate way. And then say, we want to get these low cost autonomous underwater vehicles, vertical profilers, to where they need to be autonomously, not using any people in the loop, and pick them up when they run out of energy. Now, this is an ambitious problem, but because our AUVs are tiny, we can get them to where they need to be very rapidly. And importantly, we can leverage the billions of dollars of investment in air, surface, and subsurface autonomy. Venture capital is pouring money into this now, and we're going to use their Wright's law scaling curves to put our devices where they need to be, and then use all of the advances in software as a service, cloud computing, and AI to put together an operating system to manage these very large fleets. So you can optimize the whole sensor organism, not just any given sensor. And our hypothesis, and our investors' hypothesis, is that these 3 pillars together will conspire to give us lower cost data over time. So I'm really optimistic that we can actually get this 10x reduction in this decade. So the dream of upper ocean data anywhere on the planet on demand, I think is totally achievable. I can take some questions during the panel discussion, but this is all I had to say in my prepared remarks. Thank you.